Hi there, this is Jacob Nash, Engineering Lessons, and this is our final unit discussed, Unit 4.2 on projectile motion. This is Lesson 1. This is just basically the notes, and Lesson 2 will be the final video on this channel, unless I do other engineering videos for a different course. I'm not sure if I'm going to or not, but then Lesson 2 will be on how to solve problems for projectile motion. So let's first look at some vocabulary. Speed is the distance traveled per unit of time. That can be in miles per hour, kilometers per hour, feet per second in this case. Velocity is the object's speed and direction of motion. We mostly know all these words, mostly. Acceleration is a change in velocity over a certain period of time. Gravity is the force that pulls objects towards the center of the earth. Gravitational acceleration. What this is a constant. So a constant is something that's going to be equal. It's going to be this all the time. So this isn't something you're ever going to have to find because it's always equal to the same thing. It's always 36. Wait a second. What in the world? I think I messed something up here. Hang on a second, please. Okay. Where's that thing? Sorry, that's completely incorrect. We have a lot of incorrect things on here. I don't know. Must have been tired when I was doing this. There we go. That's better. So it's going to be equal to negative 32 feet per second squared. Also, which is equal to negative 9.8 meters per second squared. So you will have to use either of those. Typically, you'll use negative 32 feet per second squared. So this is always equal to that. So when we get to the equations, when it has g in it, you will plug in negative 32 for g, or negative 9.8, depending on the situation. But you'll actually make this positive because all the equations have negative g, so negative cancels out. But we'll talk about that later. But let's talk about why it's negative. Well, gravity brings things down, and down means it's a negative force. That's why. Projectile is a moving object that occurs only due to gravity. So sometimes you can think of this as a shooting from a cannon. So that's the projectile, whatever's being shot at. And the firing angle is measured in degrees, and it is the angle at which the projectile, that should say projectile, not project, left the cannon. And it's represented by lowercase theta, which is usually what an angle is represented with in math. Anyways, but remember that kind of looks like a 0, but that's theta. In some equations, they say 2 theta, and it looks like 20, but it's not 20, it's 2 theta. Initial velocity is the speed that the projectile left the cannon, and that's represented with v subscript I. So we're going to have to find a distance, a firing angle, or initial velocity in the problems that we're going to do. So let's look at the equations for this, and this is very glitchy. I'll read out what it is, but I could not figure out how to type this onto a Google slideshow, so I had to take a picture of handwriting of it, and it didn't come out too good, but I'll have to say what that is. So for finding initial velocity, it's the square root of negative gx divided by the sine of 2 theta. That's not 20, it's 2 theta. Now, if you've watched different units, we use sine, and remember that's on the calculator. you just push the button that looks like SIN. To find theta, well, actually, the thing that's kind of interesting to me is that PLTW uses an equation where you're finding 2 theta instead of just theta, but all the questions will ask for just theta, so you'll have to remember to divide by 2 at the end. But 2 theta equals sine to the negative first times negative gx divided by vi squared. So that's how you find 2 theta. Technically, the equation for finding just theta would be all of this divided by 2. Then for finding x, we'll explain what all these variables mean in a second. You do vi squared times sine of 2 theta over negative g. So vi is initial velocity, and the unit for that is feet squared or meters squared, but usually feet squared. And if it is meters squared, that's when you would use the negative 9.8, but usually it's feet squared. Gravitational acceleration, like I said, that's always the same thing, and it's negative 32 feet per squared. Or what am I saying? Feet per second. X is the horizontal distance traveled in feet, and theta is the firing angle in degrees. Thank you for watching, and we will use these equations in the next and final video of Jacob Nash Engineering Lessons.